Hi there, welcome back. Last time we talked about the words position, distance, and displacement. And this time we're going to talk about the words speed and velocity. We've all already started talking about how speed just matters how fast you're going, and that a constant speed doesn't necessarily always indicate a constant velocity, because velocity is not just how fast you're going, but also you have to include a direction. So because speed does not require a direction, speed is going to be a scalar quantity. We only care about how fast you're going measured in meters per second. But when I ask you about velocity, velocity is going to be that vector quantity. Because it requires a direction, velocity could either be positive or negative, depending on which way you're moving. Again, we're going to call to the right the positive direction, and we're going to call to the left the negative direction. So in physics class, you can't just use words interchangeably. Which word you use has its own meaning, and it depends on a numerical sign, and that's honestly not the only difference between these. You can calculate a different speed for something than its velocity without it just being signs. Let me clarify on the next page. When solving for average speed and average velocity for a trip, these words average can be confusing. We're used to averaging things by adding them together and dividing by 2. But that is not how it's going to work in this case. You just can't average a few speeds to find your average speed, because really what we care about when we say average speed is the total distance that you have traveled and taken by the total time. So we will include all distances that you have gone divided by time. So the reason that you can't just average 2 speeds out is, let's say you're going 60 meters per second for 5 seconds, and you go 30 meters per second for 10 seconds. Your average won't be the average of those two because the time frames weren't the same. So what you really need to figure out then is, what's the total distance you traveled in the total time? And that's how you will find your average of your speed. For your average velocity, you're going to take your total displacement divided by your total time. And so really what these equations will look like is v equals d over t, or v equals delta x over t. Sometimes people put a little arrow over the v for velocity to include that, hey, that's the vector, because both of them are called v, so it's a little confusing. All right, let's apply this immediately so that you can see an example. That same problem we did last time, where we were trying to find this person's distance and displacement as they walked, we are now just going to tell you the total duration of time for as well. We're going to say, hey, it took 10 seconds for this person to start at this location, move 8 meters forward, come 3 meters backward, and then end here at this location. So as we went through in the last video, you saw that the distance that person covered was going to be the 8 meters plus the 3 meters, because really they traveled 11 meters total and the direction was not important. However, the displacement, we do care about the difference between where you started and where you ended. It's nice to draw a line from start to end, and the length of that line with the arrow on that direction from start to end, that will help you find your displacement. So I started at 0 and I ended over here. That's not 8 meters away. It's actually 5 meters away from where I started. So that displacement isn't just 5 meters though, because that wouldn't tell me, are you 5 meters to the right of your starting point or 5 meters to the left of your starting point? It's going to be positive 5 meters to indicate 5 meters to the right of your starting location. To find the average speed for this, we're going to say that speed is your total distance divided by your total time. And so your distance was 11 meters, and the time was 10 seconds. And that lets that be 1.1 meters. 1.1 meters per second. And again, speed doesn't need a sign on it. It doesn't have a direction associated with it. It's just how, on average, how many meters did you cover each second? If you did 11 meters and it took you 10 seconds, you covered 1.1 meters per second. Now, average velocity is slightly different because, again, velocity is a vector and it takes into account your direction. And so it's not just about how many meters did you cover. It's more like getting to the point of, sure, you walked 11 meters, but why? Why did you walk 11 meters when really your displacement was only 5? So we're going to take your displacement divided by your time here. We want to know your change in position divided by your time. So since your change in position was positive 5 meters, and that took you 10 seconds, really your average velocity is positive 0.5 meters per second. Again, that positive is that we're traveling to the right overall. That's your net gain. Your net gain is to the right. And so your net gain is only 5 meters. Like, why would you go 11 when you only needed 5? So your velocity is just like, hey, you only traveled plus 0.5 meters per second in those 10 seconds to get you up to a total displacement of positive 5. So you'll see here that it's not just about the same numeric answer with a different sign, because in this example, we have 2 different numbers. And again, only the sign is important on the velocity. You'll just always give an absolute value for speed, or for direction, we would say like not applicable on your Schoology practice quiz that you're gonna try. And so basically this average speed versus average velocity is going to be practiced in the packet on pages 11 and 12. So now you'll be able to do pages 9 through 12 in your packet and the entire Schoology practice quiz. And this will help prepare you for your first formative quiz coming up this week. Enjoy.